Come on, now we're live. There we go. Okay, here's what we're going to do today, okay? So grab a graphics calculator, fix the window so that they can see it. Hint, it is small. So if I take my calculator, I need to grab one myself, and I want to graph this, right? Okay, let me grab a calculator. So if I go y equals clear, and I do 1 divided by x. Okay, everybody with me? Graph. Oh, mine's really bad. Somebody's messing with my calculator too, huh? All right, let's check that out too. Format. Oh yeah. Oh yeah. You guys don't mess with these calculators, please. Graph. All right, that's a really bad looking graph. That's mine. This one's pretty darn good. This one's pretty good. You guys see this one? This one's more normal, right? Okay. That's a really good one. So let's think about this. If we have y equals 1 over x, it's really x times y equals 1, okay? So the question is, what times what makes 1, right? What times what makes 1? Well, let me go ahead and put my axes in, and I'm going to change my scales. I'm going to put my scales maybe by 1/4, okay? So my scales are going to go something like this. Maybe I'll go 1 here, -1 here. I'll go 1 here, and I'll go -1 here, okay? So, all right, let's do this. So easy, pretty easy, I think. Tell me, what times what makes 1? 1 and 1, right? So there should be a point at 1. Actually, I'm going to bring my scales in. Let's make that 2. Let's make that 2. Make that 1. That'll make it easier. So we know 1 times 1 is 1. Do you agree with that? I know that if I have 1/2 times 2, it makes 1. Does that make sense? 1/2 times 2. You guys okay with that? Right? And I also know I can have a 2 times a 1/2, and I can have a 1/4 times a 4, and so forth and so on, and the graph should look like this, okay? And the same thing, I could do a -1 times a -1, right? That'll make 1. You guys agree with that? -1 times -1, so -1, -1, there we go. I could do a -1/2 and a -2, -1/2 and a -2. I could have a -2 and a -1/2. My graph looks like this, okay? This is our parent function. That's our parent function. Okay, and what we want to do today is move it. Now, there's no real vertex. You know, there's always nice if we have a vertex, we can move the vertex. That makes sense. But there's asymptotes, and we're going to move the asymptotes. Now, the asymptotes are invisible, right? You can't see them because they're invisible, but there is a horizontal asymptote at y equals 0, right? And there is a vertical asymptote at x equals 0, right? And then they intersect at 0, 0. So the two asymptotes intersect at 0, 0, okay? So when we move these, we're going to move the asymptotes and then fit in the graph, okay? I'll say it again. So when we move these, like example 2, we're going to move it, right? When we move it, then we're going to just go ahead and move the asymptotes where it belongs. Okay, so parent function, we got it? So let's look at example 2. So what I'm going to do is I'm going to move the asymptotes to, so my center, my intersection of the asymptotes happens to be at -2, -4. Okay, so I'm going to take this graph and move it to -2, -4. Okay, let's let me put down my x-axis. So I'm going to just shift it kind of like way over here like this. So I get my -2 in there and my -4. So I'm going to kind of put my axes like this. Okay, so it'll fit. And then I'm going to put a dot. That's an invisible dot. 1, 2, 1, 2, 3, 4. That's an invisible dot. Doesn't really exist. It's my invisible dot. But that's going to be the intersection of the asymptotes. Have I lost you, or are you okay? Okay, so I'm going to take this graph here. I'm going to move it to +2. Remember the dance? Opposite the inside and down 2. So I take this graph. I'm going to move it to -2, -4. But to move it, I move the asymptotes. So the asymptotes move. Let's put the asymptotes here. See what I got? So move my asymptotes, right? So this graph is going to shift, my parent function is going to shift to here. So let's do the same thing. I know the top number is 1. So again, I need multiples. Of 1. And I know what the multiples of 1 is because we just did, okay? So if I go by, well, I already went by 1, so I'm stuck there. So if I go 1 times 1, right? Go 1/2 times 2, right? I go 2 times 1/2. I can go 1/4 times 4. I can go 4, 1, 2, 3, 4 times a 1/4. And my graph looks like this. Now I can do the same thing on the other side, right? I can do the negatives. I can do a -1 and -1. I can go -2 and a -1/2. I got -4. Okay. I can do the same thing here and here. Now, we can also check it on our calculator, okay? And I'll get a better window than the last one I had. Callan, you had a good window there, didn't you? Ooh, that doesn't look right. That doesn't look good there. Okay. So let me get my window better. Okay, window, let's do a negative. Oh, let's do a -8. And we'll do a +3. And I'll go scales by 1, and I'll do a negative, like maybe -6 and 3, and I'll do a y equals. So you can put in your calculator. Okay. So I'm going to type into my calculator clear. I'm going to go 1 divided by parentheses. You have to have parentheses. X plus 2 parentheses subtract 4, and let's see what we get. Okay. Well, now this one showed an asymptote, didn't it? My calculator showed an asymptote. Callan, what does yours look like? Oh, yours is even better. How about yours? Why is Callan's always better than mine? It's okay. I can handle that, okay? So it's even better. Because the asymptotes really aren't there, are they? Right? The asymptotes are only boundary lines. And we can imagine a vertical asymptote at 2. And we can imagine a horizontal asymptote at -4. Now, let's go back to this vertical asymptote, okay? Ready? If you divide by 0, what happens? If you divide by 0, what happens? Come on, what would Cookie Monster say if you divide by 0? You wouldn't have any friends. What x value, now think, come on, I know it's Friday morning, think. What x value right here is going to make you divide by 0? If x is -2, you're in trouble. Think about it, x right here. See where I'm looking? If x is -2, you'd have, let me rewrite this so it looks better, 1 over x plus 2 minus 4. If x were -2, you'd be in trouble, okay? You cannot divide by -2. So x cannot be a -2. So you have to have an asymptote there because the graph cannot equal -2. So what you get is an asymptote. And it goes off to infinity, but it never touches that value. It goes off to -infinity, but never touches -2 because if you divide by -2, right, it goes off to infinity, okay? All right. Now, number 3. All right. Shoot. Well, maybe if I can do some long division, it might look better. So let's do a long division problem. So go first, before we do anything, let's take a 3x minus 12 into a 2x plus 8, okay? So, ready? 3x goes into 2x how many times? Well, if you have a hard time with that, okay, you can just do a little mini division, okay? So 2x divided by 3x is really going to be 2/3. You okay with that? So if I go 2/3, then 2/3 times 3 makes a 2. Is this bothering you? This times this makes a 2, makes a 2x. 2/3 times 12. Let's see. 3 goes into 12 4 times. 4 times 2 is 8, so you get a -8. Okay. I'm going to subtract, right? I'm going to subtract. So if I subtract, I get a double negative. I subtract to make that a plus. Let's see what I'm going to get. I'm going to get a no x's, and I'm going to get a 16. Okay, so then what I have is an answer of y equals 2/3 x plus 16 over 3x minus 12, right? 2/3. Okay, now, what do I do with this? So the asymptotes. Well, I'm going to have one asymptote at x equals 4. Where did I get x equals 4 from? If x were 4 right here, what's going to happen? Right, so we know we're going to have a vertical asymptote. So I'll have a vertical asymptote at 4, right? Alright, so let's put that in there, okay? So I'm going to put my vertical asymptote at 4, so I'm going to put my graph in. And this is not 2/3 x, my bad. I'm surprised you guys didn't catch me on that one, it's just a 2/3. I knew something wasn't looking right. It's just a 2/3, not 2/3 x. It's okay, you guys are supposed to help me out. Okay, so my vertical asymptote, so if I do this, and I do this, okay, right? And I'm going to have a vertical asymptote at 4. Let me get my marker in, so I'm going to go 1, 2, 3, 4. That's it. Okay, there's my vertical asymptote at 4, okay? Now my horizontal asymptote is at 2/3. Okay? My horizontal asymptote is at 2/3, which is going to be kind of hard to see. 2/3 was right in here. Okay? I'm going to slow it down for a second because this is complicated, isn't it? Okay? So I had to do long division because I can't get the asymptotes from this. Okay? Kind of can. I kind of can get the 4 if I know I can't divide by 0. Does that make sense? If you look here, automatically you can kind of get the vertical asymptote if you know you can't divide by 0. So 4 makes sense to me. 3 times 4 is 12. 12 minus 12 is 0. Okay? Now to get the horizontal asymptote, it turned out to be 2/3, didn't it? Okay. Now, here's the next piece. I want the multiples of 16. I want the multiples of 16, okay? So, 4 and 4. Okay, so I'm going to go from here. I'm going to go 1, 2, 3, 4, 1, 2, 3, 4. I'm going to go 8 and 2 and 2 and 8, and the graph's going to look something like this. 4 and 4 is about here. The graph is going to look something like this. You can check it on your calculator and put the original graph in there. You can. If you're like, okay, I am totally lost. Okay, we can always go back to our calculator and go parentheses 2x plus 8 divided by parentheses 3x subtract 12, okay, and graph that. Okay, now, there's my graph. And I don't have enough of it. I got to get a different window or a better window. Let's go as big as maybe, let's go negative 10 to 10, see if that helps. And we'll go negative 10 to 10 and see if that helps and graph that, okay? Okay, mine's still showing the asymptote, which is okay because sure enough the asymptote is at 4. Callan, does yours here? Here, I'll Callan show hers. Oh, is this yours? Okay. Let's see if Callan's is better. But what you don't see is the horizontal, okay? All right? So this is the equation that gives me the most information. This information helps me get the horizontal is right here, asymptote, and the vertical is here, okay? And you can rewrite this one as 3 times an x minus 4. If you rewrite that, here, let me rewrite like this. Y equals 2/3 plus 16. Oh, yours is so much better. Over 3 times x minus 4, okay? Thanks, Callan. Okay, so now the 4, you can see the 4 for sure, right? You guys can see the 4? But the 2/3 is kind of hard to tell. You can't tell on the 2/3, can you? But you know the 2/3 is there from long division, okay? Now let's turn the page. This is hard stuff, isn't it? All right. So, same exact problem. Okay, let's do it one more time on purpose, okay? Right, same exact problem. Let's do it again. Okay, so objective. In this case, my objective is going to be to graph rational functions using long division. Okay? All right, let's do this problem one more time, okay? Because you kind of need it again, don't you? If you totally are with me, you totally got it, then thumbs up, awesome. But my guess is most of you are like here. Come on, be honest. Most of you are here, or maybe there. Anybody here? Okay. All right, I'm okay with honest. Let's do it again. Okay, so what we want to do is put in the form of y equals a x minus h plus k. So now a, the value a here, are the multiples. So the value of a are the multiples. Okay, a is the multiples. What times what? Remember how we did that yesterday? This number here is the multiples, okay? That's how you create it. What are all the multiples? And we create those points, okay? The h is going to be where your, the h is where your vertical, asymptote is. And the k is where your horizontal asymptote is. So Tiffany's going to take me to a spelling bee tonight, and I was freaking out. And then I remembered, hey, I can spell asymptote, and most of those guys won't be able to. All right? There's one thing I can spell they might not be able to.
Wait, but that's not how the spelling bee works.
I know, so I'm just going to sit there quietly for most of the night and just eat my dinner.
Spell cat. K-A-T.
So, let's take a look at this. So let's rewrite this. So to rewrite this, we're going to have to go straight into long division. So I'm going to take, I'll do it again, my 3x minus 12 into my 2x plus 8. Okay, let's do it again. So to get it into this form, I have to do my long division. Okay, so here's the trick. If we're going to divide 3x into 2x, and if you can't do that, then do the division on the side. So, well, Mr. Davies, how do you do that? Okay, so if you need to do a side division, I take my 2/3, my 2x divided by my 3x, because that's really what I do is divide this into this, right? So if I do a little side division, okay, well that's easy. 2x divided by 3x is just 2/3, right? So I'm just dividing that by that, right? So if I can't do it, a little side division makes 2/3. So 2/3 goes up here, okay? 2/3 goes there. Now, like all division, I'm going to multiply. I'm going to go this times this, and this times this, okay? 2/3 times 3 is 1, because you get 6/3. So I'm saying again, 2/3 times 3 is 2. That's what I meant to say, is 2. So I get a 2x. 2/3 times negative 12, okay? 3 goes into 12 4 times. 4 times 2 is 8. You want to do that again? Or a little side. If you're not sure, you can go to negative 12 times 2/3. Okay? 3 goes into 12. 4 times 2 is 8, right? So it makes a negative 8. Okay? But we're going to have to subtract, right? So we subtract. Change the sign because I'm subtracting. And then I wind up with 16. Okay, now, here's my answer. My answer is going to be in this form. My answer is going to be y equals 16 over, and let me rewrite this too, plus 2/3. I rewrote this so you can see the asymptote, okay? I mean, 3x minus 12 is the same thing as 3 times x minus 12. You guys okay with that? I just factored it. Plus minus 4, right? So I just took and rewrote this in factored form, okay? Or I could have written 2x plus 8 as 3 times x minus 4, okay? Now, right off the bat, I know where the vertical asymptote, you can't divide by 0, right? Cannot divide by 0, right? So x cannot equal 4. That's where my vertical asymptote is, okay? And my horizontal asymptote is at 2/3. My multiples are 16. So, my equations, my asymptotes are x equals 4 and y equals 2/3, all right? So if I'm going to go ahead and put this on my graph, okay, I'm going to go, I'm going to do 2/3 and negative 4. I guess that doesn't really matter too much. Kind of put it like this. All right. Have I lost you? Are you better on this one now? Second time through it? A little bit better? Olivia says no. Okay. Vertical asymptote, right? Vertical asymptote. 1, 2, 3, 4. Vertical asymptote, okay? Horizontal asymptote, but 2/3, so it's just barely right there, okay? Multiples of 16, positive 16. 4 and 4. 4 and 4, 16, let's see, 8 and 2, 2 and 8. So the graph looks something like this. Negative 4, negative 4. 8, negative 8, and negative 2, negative 2, and negative 8. My equation looks something like this, okay? All right? And if you had a halfway decent calculator like Callan does, but you can't get the horizontal asymptote too easily, can you? One thing you could do, you want to see one little trick? If you go to your trace button, okay, watch the trace button. Come on. There it goes. Okay, watch the trace button and watch the corresponding y value. Watch the y value. You watching the y value?
I can't tell.
But you got to go a long ways because you're going to infinity. I'm kind of waiting for it to flatten out. Really messing up my, okay. So what's it approaching? Look at the y values. 0.9, 0.9, 0.9, 0.89. But it's going to take a long time to see if it approaches what? We know it's going to approach 2/3, right? But I can keep going. It's like I keep going. Okay, well, am I getting close to 2/3? 0.8. Takes a long time because we have to go to infinity. You got to go to infinity to get to 2/3. So what's the only way to really go get that asymptote is by long division. Sorry about the bad news. That's the only way. Okay, so let's look at your journals real quick, okay? And I'll help.